Hi, this is the presentation of Jianfeng Zhang for the homework 6, and this is the problem 1. We have got the density function of x and y equals to a times 1 plus xy, and the train is that the absolute x is little than 1 and y is also little than 1. Okay, and the first question, we need to find out what is the a to make a valid joint density function. And it is very easy to figure out this problem. We can use the integral of the joint function for all the region that xy can get from infinity to infinity, and that equals to 1. And if we look at this condition, and we can figure out that x and y are both in -1 to 1. So we can see that it is like a square. Okay, and we change this region like to this one, to -1 to 1, these two edges. And okay, and next we're gonna do is to figure out what is the integration result. Okay, after we finish that, the integration is 4 times a, and this equals to 1. So a is equals to 1 over 4. Okay, that's easy. And second question we need to figure out is x and y are uncorrelated. And with the definition about uncorrelated, we knew that if the expectation of xy equals to the expectation of x times equals expectation of y, then these two random variabilities are uncorrelated. So firstly, we need to figure out what is expectation of x and y. And okay, we see this one is in the definition of expectation is like this, and of y is also like this, and for xy it is like this, also integration from -1 to 1. Sorry, this is -1 to 1. This is double integration, and for now we don't know what is the PDF of x and y. So firstly, we need to figure out what's the PDF of x. So the PDF of x equals to the integration of the joint distribution, the joint function from -1 to 1, because x is because the absolutely x is -1. So the expectation of so the PDF of x is right like this. After integration, we can find out that the PDF of x equals to 1 over 2. And because we see that in this function that x and y are symmetrically, so also we can easily get the PDF of y is 1 over 2. So after we get 2 of this, we can easily to figure out the expectation function, and after integration we can find that the expectation of x and y are both 0. Okay, next we need to calculate the expectation of the joint function of xy. So after this integration, we can find out this kind of expectation is equals to 1 over 9. So it's easy to see that the 1 over 9 is not equals to 0 times 0. So this is uncorrelated. And thirdly, in the third question, we need to find out if x and y are independent. And it's easy to find out that the joint function is not equals to the multiply of the two PDF function. So therefore, they are not independent. And the first question, let me see. The first question, we need to find out the joint density function of x squared and y squared. And the fifth question is to prove that the x square, whether x square and y square are independent. So the method is similar to the first three questions. And okay, and for first question, we need to figure out x square and y square. Okay, we make z equals to x square and w equals to y square. And for the region is for z and w is all more than 0. And also we need to attention that x and y are the absolutely of x and y are little than 1. So we can find out w is in 0 and 1 and z is in 0 and 1. So the distribution function of these two new random variable is the integration of the PDF of the joint PDF of x and y. So we can write like this. Okay, and we draw the region of w and z. We see w and z as a constant, and so if w is here, so in the xy region is like this, is also a square. So after this integration, we can figure out that the distribution function is like this. And how about the PDF function of these two new variables? So we're gonna to do the differentiate. And after the differentiate of this kind of equation, we can find out the density function, joint density function is like this. It is 4 times x and y for absolutely value and 1 over this value. Okay. So we're gonna figure out the last question. And in the last question, we need to also figure out whether these two new functions are independent. So the best thing we're gonna do is to figure out if the times of the two PDF new random variable functions is equals to the joint function. So it's similarly with the integration of these two functions, we can figure out that these are equals to 1 is equals to 1 over 2 times z with the power of minus 1 over 2, and for w it is very similar. It's equal. It's even the same. So we can figure out that these two functions are equal. These equations are valid. So in this question, that x squared and y squared are independent. Okay, and this is the first question. First problem. Okay, for second problem, it is a similar condition that we have got a joint density function and equals to a, and the region is a circle. Okay, we drew like this because x squared plus y squared is little than 1, so it is a circle. And the first thing is also find an a, and to make this PDF function is to make this joint density function is valid. So we also make an integration in this circle and to make it equals to 1. So after integration, we can easily find out that a is equals to 1 over pi. And the second question, we need to find out the expectation and also about all the condition expectation. And at the first, I try to figure out what is the PDF function of x and the PDF function of y identically. But I think it is not a very easy method. So with this method, and we can figure out that the expectation function of x is equals to this, and we see that this one is a constant, and with the region of square in 1 minus x squared to this one, and Also, after this integration, and we found that this kind of thing is an odd function. So we don't need to figure out what is the integration because it is an odd function. So after the integration, this kind of equation must be 0. So it's got much more easier. And this is expectation of x and is equals to 0. And if we look at the PDF function and the region, we see that x and y are totally symmetrical. So we can know that the EY is also 0. And we see that, and it's very easy to see because the expectation of x and y are all 0. So the conditional in value of y for the expectation of x must be 0 because in every place x is also 0. So it's easy to find out these 4 equations are both 0. These 4 expectations are both 0. And now we're gonna figure out what is expectation of x times y, because we can see we use this integration function and we found after the integration of y, we found it is like this. Okay, see this part. And in this part is also equals to 0 because there is a y square and the top edge and the bottom edge are totally the same after the square. So after the minus, this integration must be 0. So it's easy to figure out that in the third question, the expectation of xy equals to 0, and these two are both equals to 0. So this equation is valid. Therefore, x and y are uncorrelated. Okay, that's all. Thank you.